Hello everyone! Continuing with our discussion on probability, now in this particular problem, we've been told that a student has to take 3 tests, test 1, 2 and 3. A student will pass if he clears either test 1 and 2 or test 1 and 3. Now the probability of clearing tests 1, 2 and 3 respectively are P, Q and a half. Finally, they've told us that the probability that a student is successful is 1/2. So let me call probability of being successful in test 1 to be event A, success in test 2 to be event B, and success in test 3 to be event C. The objective of this problem is to find out P and Q, which are the probability of success in test 1 and test 2. In other words, probability of event A and probability of event B are what we have to find out. So they've told us that the probability that a student is successful in the examination is half. When does a student become successful in the exam? If he clears test 1 and 2 or test 1 and 3. So this means probability of A intersection B union A intersection C is nothing but half. So for any two events, let's say E and F, probability of E union F is probability of E plus probability of F minus probability of E intersection F. So in our case, this is nothing but A union B, A intersection B is nothing but E and A intersection C is nothing but F. So what is probability of A intersection B union A intersection C? It's nothing but probability of A intersection B plus probability of A intersection C minus probability of A intersection B intersection A intersection C. Now what is probability of A intersection B intersection A intersection C? So A intersection B intersection A intersection C can be simplified and written as A intersection B intersection C. So we know that probability of A intersection B plus probability of A intersection C minus probability of A intersection B intersection C is 1/2. How do we proceed from here? Now this is where your knowledge on independent events come into picture. Because a student passing a test is independent of the student passing or failing another test. So how a student performs in one test is independent of his performance in another test. So events A, B and C, which are success in exam test 1, test 2 and test 3 are independent of each other. So I can write P of A intersection B as P of A multiplying P of B. In the same way, I can write P of A intersection C as P of A multiplying P of C, and finally P of A intersection B intersection C as P of A multiplying P of B multiplying P of C. Now they've told us that P of A is P, P of B is Q, P of A again is P of C is 1/2, P of A is P of B is Q, and P of C is 1/2. So upon putting in all these values, I get an expression which is PQ plus P is equal to 1, out of which if I take P common, I get P multiplying Q plus 1 is equal to 1. So P multiplying Q plus 1 is equal to 1. Now this equation has infinite number of solutions, because if Q can take the values between 0 and 1, then P also will take appropriate values such that P is also lying between 0 and 1. So we have to check which of the given options now are correct, because this problem has infinite solutions. We have one equation and in fact one equation with 2 variables. So there are infinite solutions. So let's check which of the options match. 1, 1 is option A. If I put 1, 1, I get 2 is equal to 1. Not right. Half, half, I get half multiplying 3 by 2, which is also not equal to 1. 1, 0 gives me 1 is equal to 1. So in fact, option C, which says 1, 0 for the values of P and Q, is the right answer to this particular problem. So option C, 1, 0 is the right answer for P, Q.